Here's the problem that we're going to be solving today. Determine the values of m and n so that the polynomials 20x cubed plus mx squared plus nx minus 30 and 10x cubed minus 3mx squared plus 2nx plus 40 are both divisible by x minus 2. Here is the full solution to the problem. Let's go through each step. First, since we're dealing with two different polynomial functions, let's set the first polynomial function to f at x and the second polynomial function to g of x. Using the remainder theorem, we know that if f at x is divided by x minus p, then the remainder is f at p. Using the factor theorem, we know that x minus p is a factor of fx if f at p equals 0. Since the question stated that both polynomial functions are divisible by x minus 2, it means that x minus 2 is a factor of both polynomial functions, which means when both polynomial functions are divided by x minus 2, the remainder is 0. Since our p-value is 2, we can say that both f at 2 and g at 2 equals 0. Now that we know this, our next step is to sub in f at 2 and g at 2 into their respective polynomial functions and have them both equal 0. Because we are trying to find the values of m and n, first I simplified both polynomial equations, then I added or subtracted like terms, and then rearranged so that m and n will be on the same side for both equations. This lets us end up with two equations, of which we labeled 1 and 2. The first one is 4m plus 2n equals negative 130, and the second one is negative 12m plus 4n equals negative 120. Now that we have these equations, we can solve for both m and n. First, you pick one of the variables that you want to solve, and in this case, I chose n. In order to solve for n, you want to isolate n, and in order to isolate n, we want to cancel out the value for m. We can cancel out the m value by making sure that the m value in the first equation is equivalent to the m value in the second equation. Since the m value in the second equation is negative 12, we know that we also want the m value in the first equation to be 12. To do this, we will multiply the entire first equation by 3, and leaving the second one as it is. This will let us end up with 12m plus 6n equals negative 390, as our new first equation. Now to get rid of 12m, we can do either one of two things, add or subtract. Since we are dealing with positive 12m and negative 12m, that means we'll have to add them together to get rid of them. This also means we'll be applying addition to everything else. This will get us to 10n equals negative 510. And because we want to isolate n, we will divide both sides by 10, which will give us n equals negative 51. Now that we know the value of n, we can solve for m, and we do this by subbing n equals negative 51 into any of the two equations. In this case, I picked the first equation. After we sub in n, all we have to do now is simplify, add and subtract like terms, and rearrange so that m is isolated on one side. This will give us 4m equals negative 28. Like before, now we will divide both sides by 4, so we end up with m equals negative 7. Therefore, our answer is m equals negative 7 and n equals negative 51.